Deal. We're at a last week of the quarter. And I need to always sprinkle in some of our 8th grade standards. So this week, we're going to do stuff that you've already done. But I always like to give you a reminder because this stuff is what's going to show up when you test in May. And I don't really want to stress about when you test. But just so you know, I want it to be a refresher. So could we move on to the next chapter and I slam more material in your face? We could. But I also don't like to start a quarter with a quiz. And if we had started chapter 4, we would start next week with a quiz, which would not be the greatest thing to start the quarter with. So what Mrs. Hoosier and I decided to do, we're going to cover some things this week, 8th grade standards. I'm not going to give you an assessment on it, but we're going to do an in-class activity on Friday. You should still go home for the weekend without any homework. Cool? We will start chapter 4 on Monday. Cool? All right. So today is scatterplots. Data with 2 variables or pairs of numerical observations are called bivariate data. Bivariate data. Two sets of data is going to be graphed on the same coordinate plane, and that is called a scatter plot. A scatter plot shows the relationship between the bivariate data, graphed as ordered pairs. Now here's the deal, because it's data that we collected, it doesn't always look perfect. Okay, some of these are just going to be crazy all over the place, hence scatter plot, right? Okay, so it says construct a scatter plot of the weight of an alligator at various times after hatching. It gives us the table and it wants us to put it on the graph. First things first, we need to label these. The X column is always on the left. The Y column is always on the right. So our X-axis should be labeled weeks. Our Y-axis should be labeled weight. Now a scatter plot is just plot those points. Are you going to be able to be exact? No. Are you going to try to be as accurate as you possibly can? Yes. So take a minute, 3, 6, looks like there's 7 points to put on that scatter plot. Yours should look pretty close to mine. Agreed? They might be off but just a hair. But overall, you shouldn't have like something up here in this left-hand corner. All right, scatter plots, pretty straightforward. There are different types of association. Variable association and linear association. So every time that you see a scatter plot, we can actually characterize or put it into a grouping based off of different associations. So here's an explanation. Variable is talking about the slant. Think of it like slope. Agreed? A positive association means it's going up and to the right. A negative association is down and to the right. No association, Ms. Hoff calls mass chaos. Okay? Now, here's the deal. Scatter plots, they're not necessarily going to be lined up perfectly in a line. You're looking at the overall trend. Okay? Are they overall trending up and to the right or overall trending down and to the right, or are they just absolutely everywhere? The linear association is a lot more straightforward. Linear or nonlinear? Same thing though, they're not going to make a perfect line. I always say, if you could take a Sharpie and draw a line and touch nearly every point, it's probably linear. But if there's any type of hook or change in that a ruler wouldn't go through, then you're looking at nonlinear or not a line. So if I was going to go look at what we just did, variable association, positive, negative, or none? I'd say positive, absolutely. Linear or nonlinear? Bless you, absolutely linear. The last piece, bless you again, is also outliers or clusters. Outliers can be 1 to 2 points that are totally off of what everybody else is showing. And then a cluster is like a groupie. Like, interesting, there's a whole chunk of points right here. So today, we're going to look at these 3 things. Variable association, linear association, and then clusters and outliers. Okay? Flip. Interpret the scatter plot for the data for the time elapsed and temperature of water based on the shape of the distribution. Variable association. As the time increases, which means we are moving to the right side of the graph, the temperature of the water decreases. So the scatter plot shows a negative association. Nicely done. Kind of grouped in some end behavior there, yes? As it increases, our y value decreases. Linear association. The data appears to lie close to the line, so the association is linear. Other patterns. There are no outliers or clusters. No outliers, no clusters. Okay, you take a minute. Describe for me on the next graph the variable association, the linear association, and your outliers and clusters. See what you can write on there. You want me to put that up here so you can look? Here's your associations here. Bless you. Don't get too crazy. I'm not even necessarily looking at end behavior here. That was just easing you into what you're going to look at. So on this one, what can somebody tell me about the variable association? Jackson? I would say no association. I call that utter chaos. Agreed? There's no trend. They're not all trending upward or all trending downward. So I would say no association. Who's got something for me for linear? Thatcher? Non-linear. I would say it's non-linear. It's either a line or it's not a line. And in this case, non-linear. Here's a question for you. Can you have no association that's linear? Then they would be in a trend, agreed? You'd have a trend happening. Could you have positive association that's nonlinear? It's going up, but it's a curve of some type. Other patterns. Clusters? No. I don't think so. When you have mass chaos, can you really say, well, here's a group of mass chaos? Agreed? And if you have mass chaos, are you going to have an outlier? Everybody's just everywhere, yes? So on a no association, it's pretty straightforward. No clusters, no outliers. No clusters, no outliers. Clusters and outliers are going to be very obvious, and they're going to happen when you see a different trend occurring, or when you see a trend occurring. In this case, where no trend makes it really hard. Okay? So now they're going to put the two words, both associations, together. This scatter plot shows a negative linear association. Negative linear association. Down and to the right, but yes, linear. Good job with linear. Some people are like, oh, but it dips down right here. They're not going to be perfect. If I took a Sharpie, I'm going to probably cover everything. There are no clusters or outliers. How could we ever predict the winning time in 2016? Jackson? An approximate, agreed. You probably give a best guess. Are you going to be spot on? No. If we look at our scale, the scale is going up by, well, the numbers are going up by 8s, right? But see how they skip a line in there? So really this very last one would be 2016, agreed? But Jackson's absolutely right. We'd have to be able to kind of sketch what we think, and I can't use a ruler, so this is always terrible when I try to do this. But you got to kind of have that. Anybody know what that line is called?
Linear line.
Linear? All lines are linear. Because is that the perfect line for that graph? Is my line going to look the same as anybody else's in this room? It's not going to necessarily be identical. Do you remember the phrase line of best fit?
No.
You worked that last year, and we're going to work it again this year. So this would be the line of best fit, a line that most closely resembles your data. Okay, but if I look at the line of best fit Miss Hoff just drew, it kind of looks like I got the winning time to be 0. Boom, good observation. Does everybody see that? Yeah. Is it really 0? No. We put a big break in there. We went from 0 to 46. So most likely, if we were going to really predict 2016, we would need to make our graph scale differently. Okay, nicely done. We could just write on here line of best fit. And again, it's not always going to be the same for everyone. Okay, main ideas all go back to this. Variable association, positive, negative, or none. Linear or nonlinear, and then you're looking at clusters and outliers. Do you want me to keep talking or leave you alone?
No.
Rock and roll. The rest of the hour is yours. That was